Hi everyone, this topic is called limits to infinity. So looking at this picture right here, I can come up with 4 limits and they're all going to involve infinity. And it doesn't show on this graph, but you should imply that we've got arrows going here, and also it's implying that it's getting closer and closer to those lines. All right, the first one I want to talk about is the limit as x approaches infinity, and we'll call this graph f of x is equal to. So this question is saying, hey, as my x value is getting bigger and bigger and bigger and bigger, what happens to my y value? Well, where is my x getting bigger and bigger and bigger? Well, that's over here. In fact, it would be even further over here. So this graph is going like this. It's getting closer and closer to the x-axis. So what is happening to the y value as my x is getting bigger? Well, my y value is getting really close to what? If you said 0, you are correct. All right, what about the limit as x approaches negative infinity? Negative infinity is basically saying really, really, really big negative numbers, like, I don't know, negative 10 million, negative 20 billion, negative 100 trillion. So what type of values are those? Those are my x values way over here. And what we care about for the answer of our limit is what's the y value. So we're talking about going over, and we're getting closer and closer to a y value of 0. We never hit it, but limits are all about what we're approaching. So our limit's going to be 0. What about the limit as x approaches 3 from the left of f of x? Well, from the left, we're talking about this right here. Okay, so we're approaching 3 from the left. Well, what's the y value that we're approaching? Well, as we get closer and closer to 3, we're going further and further down. And so our limit is going to be equal to negative infinity, because we're going down. These y values, at this point it's negative 20, but as we keep going closer to 3, we're going to be way down here. Our y value is going to be way negative. And oftentimes some people will put in parentheses does not exist if your answer is actually equal to an infinity or a negative infinity. I'd like to get in the habit of just answering it like this, but do know that a college professor might want you to say that. Both answers are correct. And why don't you figure this one out? What is the limit as x approaches 3 from the right of f of x? Okay, as we're approaching 3 from the right, we're going further up with our y values. In fact, that arrow implies we're going on forever, so you should have said infinity. And if you want in parentheses, you can say does not exist. So that's just a quick intro to limits to infinity. And I want to emphasize that limits to infinity oftentimes determine if there are horizontal asymptotes. And you can see that here, that there is a horizontal asymptote at y equals 0, but there also is a vertical asymptote as well. So limits to infinity help us with asymptotes. All right, what I would do right now is actually pause this video and I would get these notes down and then we'll discuss it. All right, welcome back. Notice on this page that what we're talking about is the limit as x goes to infinity. And if this kind of bothers you thinking about conceptually, think about x being something like 10 million or a billion or trillion, something really, really big. Obviously, we can never get to infinity because it keeps going on forever, but we can think about the idea of x being really big. So let's talk about number 1 here. If we have the limit as x approaches infinity of x to the a over x to the b, and a is smaller than b, then the limit is 0. Let me give you an example. The limit as x approaches infinity of x to the 7th over x to the 10th. Okay, in this case, my b is the bigger one, right? B is greater than A. Or you can think of it as A being smaller than B. In any case, what we have a situation here of is the denominator being bigger. If I plug in a huge number here, it's going to be a trillion to the 10th power. And if I plug in a trillion here, I'll get a trillion to the 7th power. And ultimately, what this ends up being is a huge number and then we've got a big number. You could think of this as being way bigger than the numerator. So what happens when we have something small, like let's give an example of like maybe 25 divided by something huge? Well, you can try plugging that in your calculator if you want, but essentially what we're getting is something really close to 0. So our limit's going to be 0. And although you might say, hey, Ms. Sorensen, x to the 7th is going to be big as well, maybe more like something like this, that may be true, but this way outweighs the x to the 7th. It is way bigger. So if your denominator exponent is bigger, then your limit's going to go to 0. All right, let's go ahead and take a look at the next one. This particular example says, what happens if your exponents are equal? Right? What if A and B are exactly the same? So what if you have something like, I don't know, 2x to the 7th over 4 x to the 7th? Well, plugging in these huge numbers, you're going to have a huge number and a huge number, but those numbers are going to be exactly the same, and they're going to cancel out. And so essentially what you're left with is just the ratio of C over D as your limit. In this case, 2 over 4, or 1/2. So again, if the limits are the same, if the exponents are the same, then your limit is going to be the ratio of the values in front of your x, of your coefficients. Oops, that should have been a 2. That's my bad. All right, next one, let's take a look at number 3. So number 3 is the last situation, and that's when your numerator is bigger. All right, so example 3 is going to be a situation, and it doesn't matter if you have anything, in addition attached to it, like maybe you have a 4x to the 11th over 27x cubed. All we care about is what's going on with the exponents, because let's be honest, 4 and 27 are not going to make a big difference at all with our limits. They're just small numbers compared to approaching infinity. So in this situation, what we're going to get is something huge divided by something big, but in reality, it's going to be relatively small compared to the numerator. So that's going to be something like, obviously this is just an example, something like a huge number like that over. All right, so even though this denominator is pretty big with an x cubed, the numerator is way bigger. And what's a huge number divided by another number? Well, if this number is going to get extremely big, and this number is big, but not that big, then we're going to end up with an answer of infinity. Sometimes we could end up with a negative infinity, and we'll talk more about that later. All right, let's go ahead and do the following. You might want to pause and try it on your own if you'd like. Case number 1, what's the limit as x approaches infinity? Well, we actually don't care about any of this, and the reason why is it just doesn't have an impact on the numbers. It may add or subtract a little bit, but not enough to make an impact. So here we have a much bigger value in the denominator, so we're getting a small divided by a big, and that's going to give me a 0. All right, in this next case, we remove everything else. You can put a 1 here. Notice that we've got an x squared and an x squared, which you can think about as canceling, and our limit ends up being a negative 3, or just the ratio of those two. All right, last case, we end up having an x cubed, and then we end up having an x. This ends up being way bigger, so it's going to be huge divided by something that's smaller than it, And so you're going to end up going to infinity. Fantastic. All right, what would we do in a case like this? Well, in a case like this, you're going to have to just completely ignore the rest, like this. And you're going to simplify it. And I know this feels weird, but we're just generalizing. We're trying to figure out what's bigger, what's smaller. So what is the square root of 2? Well, I'm just going to write that as the square root of 2. And what's the square root of an x to the 4th? Well, square root of an x to the 4th is going to be an x squared. That makes sense because x squared times x squared gives me my x to the 4th. And now it's going to be divided by 2x. And now this looks like a problem that we can compare both our numerator and our denominator. Here we have an x squared, here we just have an x. In this case, we're going to have bigger on top, smaller on the bottom, so our limit's going to go to infinity. All right, same thing here. Let's go ahead and get rid of this, get rid of that. It doesn't make any impact. And notice our trick here was that this is a square root. You just have to do 4 divided by 2 to get that 2. So same thing here, 12 divided by 3, we get that that's x cubed. Oh, just kidding, x to the 4th. I'm a rascal. And if you don't believe me, x to the 4th times x to the 4th times x to the 4th is x to the 12th. Okay, and then this is divided by x cubed. And so here again, we're going to have a limit that goes to infinity because x to the 4th is bigger. All right, here's some harder ones. And before we tackle the first one, I just want to remind you that the cosine graph oscillates. And what I mean by that is my cosine graph starts at 1. It also ends at 1. To pi. In the middle at pi, we've got it going down to a -1. See how well I can draw this? Whee, something like that. So why do I bring that up? I bring that up because cosine graph just keeps going up and down, up and down, up and down. And so when we plug anything into it, it's just going to change, right? So if I'm plugging in a big number here, depending on what it is, it's going to change. So it's either going to be a 1 or a -1, or it could be a 0.5, a 0.2. So in this case, the limit is going up and down, up and down, up and down. So in this case, the limit does not exist. You can go ahead and you can try to graph that if you want, and you'll find that that limit goes up, then down, then up, then down, if you look at x going to be really, really small. All right, this next one, though, we can evaluate. And we're basically just going to plug in. We're going to put an infinity here. And then we have cosine times 1 over infinity. Well, what is 1 over infinity? That's 1 divided by a really huge number. So this thing right here ends up being 0. So you have infinity times the cosine of 0. Well, what's the cosine of 0? We know it's 1. So this would be infinity times 1, which is equal to infinity. All right, and the last thing I want to bring up here is, what's the sine of infinity? Well, again, just like this number 1 here, it oscillates. So the highest that this can be is a +1, and the lowest this can be is a -1. So basically, does a +1 and a -1 make any impact on this? No, not at all. So you're just going to have that disappear, because who cares about adding 1 or subtracting 1 or adding a 0.5? All right, so this is going to end up being the limit as x approaches infinity of 3x squared over 4x squared. Well, we know that when our exponents match, we just take the ratio of our coefficients, and this answer is going to be 3/4. All righty. This here is going to be your homework, and I do want to tackle a couple problems because some of them are a little bit challenging, and I haven't brought up a few facts here. So let's go ahead and let's do number 1. So number 1, the limit as x approaches infinity of 7 is just going to be, let me get a different color, be a lot of black here. It's going to just be 7. And then what's the limit here? Well, 3 times infinity is a huge number, so you're basically going to get 1 over infinity, and that's going to give you 0. You can think of this if you want as x to the 0 and x to the 1, so that's bigger. And then this is going to be, the limit of this is also going to be 0, so we've got a minus 0. So I'm bringing this up because, remember, our limit properties state that if I have multiple things, I can just think of this as the limit of 7, which is 7, and adding it to the limit of that, and then subtracting it from the limit of that. All right, I'm going to find another one that I think that we should do. Let's take a look at number 6. Number 6 has a limit as x approaches negative infinity. And when your answer is going to be infinity or negative infinity, sometimes you have to worry about your sign. So for example, in this problem, we know that we've got a cube over a squared. So if you go back to our rules, and I promised you I would go back to this, sometimes we're going to get an infinity or a negative infinity. All right, it just depends on the problem. So this always has to do when the numerator is bigger. So for example, on number 6, think about what happens when you plug in a negative infinity to a cubed. Okay, well that's going to be a negative times a negative times a negative. So on top in the numerator, you know you're going to get a negative. In the denominator, when you plug in the negative, you get negative times negative because you're squaring it. So you're going to get divided by positive. So what is a negative divided by a positive? Well, of course, it's a negative. And then don't forget about finding the answer. Of course, when we have a bigger value on top, that is going to give us an infinity. And in this case, it's going to be a negative infinity. And also be aware of the fact that you've got these coefficients as well. That does impact the answers. So number 6 is negative infinity. All right, I also want to go over, let's do number, how about number 14? Let's definitely do number 14. So number 14 here, again, we have a bigger value in the numerator than the denominator, in which case we know that the answer is going to be infinity or negative infinity. So we can cancel out the 3 here, it makes no difference. We can cancel out the -1. These are things that have no impact on the problem. But what happens when I plug in an infinity into the squared? Well, that gives me a positive, but I have the -2 here. So I'll end up with a negative divided by, okay, plugging an infinity into here, I'll end up with a positive. So I know my answer is going to be negative. But what's the answer going to be? Well, remember, we've got a bigger exponent and then a smaller exponent, so that is going to be an infinity. All right, we'll certainly go over this homework in class and answer any questions that you have. Thanks, everyone.